For this problem, you're given the graph of the derivative. So think about what the derivative is telling you about the function itself. Go through and find the intercepts, because you know at those intercepts those are going to be critical points. Your instantaneous rate of change will be 0. And then just create intervals of where it's positive and where it's negative. So to the left of this critical point, your graph is above the x-axis, means it's positive, which means that your function is increasing. Between 0 and 4, the derivative is below the x-axis, it's negative, so it's decreasing. And then between 4 and 10, it's above, so it's increasing. And then to the right of 10, even though 10 is a critical point, it's still above the x-axis, so it's still increasing. Okay, so now let's look and see what's happening with the so let's mark where it's increasing and decreasing. So this is what, when you sketch the graph of your function, you just want to make sure that across these intervals that your function is doing these things, that it's increasing, decreasing, increasing, and increasing. And then we'll go through, we know that because it's changing from increasing to decreasing, that's a max. It's changing between decreasing and increasing, so that's a min. And it went from increasing to increasing, so it is a critical point, but it's neither a max nor a min. Well, again, we're looking at the derivative, and I notice that the rate of change, that it's continuing to decrease to this point here. Okay, so that means that when we get back to that just means that your graph is going to be concave down, and then your slopes are going to continually increase to this point. Then they're going to continually decrease until they get to 10. So what does that tell us about the concavity? Well, along this first interval, it's going to be concave down, because that's where the slopes are decreasing. Along this next interval, we know it's going to be concave up, because that's where your slopes are increasing. Concave down, concave up. And these are going to be inflection points. So let's go ahead and let's just start sketching it. I'm not interested in an accurate graph. I just want a sketch. I want you to make sure you have the maxes, the mins, where the function is increasing, where it's decreasing, and then also your points of inflection. So here we have it increasing. We get to a max. Then it's going to start decreasing, and at this point we have an inflection point. It's still going to decrease, but now it's concave up. We get to this point where we reach a min, and then it's going to start increasing again till we get to this point, which is another inflection point where it's going to switch from being concave up to concave down. But it's still increasing. And then we get to 10, where we have that interesting point where we didn't know what was going to happen. Well, what does happen is that it's going to continue to increase, but it's an inflection point, and it just increases up. So that's just kind of a general sketch of what that function might look like. There's going to be variations of the sketch. People are going to do different kinds of sketches, but it has my maxes, my mins, and my inflection points.